Mark your own. Oh, my favorite student. Good old Ann Serkey. So number one, we have two objects moving at different speeds. We said for these situations, A is going to be 0. In fact, A is 0 for all of these questions. We're not, Kenta, going near the speed of light, so it wants the speed of the rabbit relative to the wolf. We call that VREL, was my abbrev. It said speed, so 8 meters per second. I didn't ask for velocity, so I don't care about positive or negative. If you said negative, I'm not going to freak out, but speed's a scalar. It just wants the magnitude. And then if the rabbit has a head start, how long will it take? Okay, so now it wants me to find time. It looks like they gave me a distance, and I have from the previous question, VREL is 8. What we're going to be using is D equals VT, technically plus a half AT squared, but what's A equal to, Cameron? So half AT squared is also equal to, same answer, 0, so it's just that. I guess I want to get the T by itself. It's going to be D over VREL. It's going to be 12 divided by 8. Doing it in my head, is it 1.5? Seconds. If you got that, 2 out of 2. Otherwise, I would give you 1 mark if I saw that, a half mark for the numbers, and a half mark for the answer. Number 2, a little trickier, but here's what I noticed. They want me to find the speed. Now, it does say in kilometers per hour. I'm going to do everything in meters per second, and then I'll convert it with a 3.6 at the end. So I thought to myself, I think they're asking me to find VREL. And again, remember, I'm using D equals relative speed times time. So I said they must have told me a distance. Yep. They must have told me a time. Yep. So if I get the V by itself, I guess V is going to be D over T, and that's relative speed. It's going to be 180 divided by 4.8. So I went to my trusty calculator. I said, okay, 180 divided by 4.8, 37.5. And that's meters per second. Now that's the relative speed. That's how much faster the police have to go than the bad guys. So really, I want to add this to the 90, but my units don't match. So then I said, okay, I'm going to convert that to kilometers per hour. I think it's times by 3.6. I said that's 135 kilometers per hour. That's how fast the police would be going if the bad guys were at rest. Are the bad guys at rest? Nope, they're going 90 kilometers per hour. So I said, okay, the police is going to be 135 plus 90, which I think is 225 kilometers per hour, I think. If you got that, 3 out of 3. Otherwise, I would probably give you a half mark if I saw that, a half mark for the numbers, a half mark for the 37.5, a half mark for converting it to kilometers per hour, a half mark for realizing you needed to add the numbers together, and then a half mark for the answer, something like that. Number 3, now I said, you know what? I'm seeing near the speed of light. This is going to be time dilation. How much time will pass on the Earth? That's asking me to find T. That means, Hollis, they must have told me T0. Yep, 8 years on board the spaceship. V is 0.99 C. So I said it's going to be T equals T0 divided by, and Derek, we learned there's an abbreviation for that square root of 1 minus V over C all squared. It's a Greek letter gamma, which sort of looks like a skitty fish doing a headstand. So I said it's going to be, oh, we got someone coming in. It's going to be 8 divided by the square root of 1 minus 0.99 C over C all squared. Do you see? Do you see? Yes, I see. It's going to be 8 divided by the square root of 1 minus 0.99 squared. Is it 56.7? If you got that right, I would give you 2 out of 2. Otherwise, I would give you 1 mark if I saw the equation, a half mark for the numbers, and a half mark for the answer. Number 4 is basically the same question as number 3, but with different numbers. I said, okay, they want me to find t again. T0 is 12. V is 0.96c. So again, it's going to be t equals T0 all over the square root function. It's going to be 12 divided by the square root of 1 minus 0.96c over c all squared. Do you see? Do you see? Yes, Duick, I see. So it's going to be 12 divided by the square root of 1 minus 0.96 squared. You'll get 42.9 if I round off properly. If you said 42.8, I would take a half mark off. Same as before. 1 mark, half mark, half mark. And then we turn the page, I think. Now they want time on board the spaceship. I said now they want T0. Okay. I guess T is 16. V is 0.99c. So if I get the T0 by itself, I think I multiply the square root function over. And so it's going to be 16 times the square root of 1 minus 0.99c over c all squared. I see, I see, I see. 16 square root of 1 minus 0.99 squared. And I get, is it 2.26? 2.3? Same as usual, 1 mark, half mark, half mark. And number 6, same question, finding T0. T is 15. Okay, we're going faster. We're going 0.995c. So I think the time dilation is going to be more noticeable. T0 is going to be t times the square root function. It's going to be 15 times the square root of 0.995c over c all squared. Of course, I see. 15 times the square root of 1 minus 0.995 squared. You get, I guess this I'd have to round to 1.5 unless I go with a lot of sig figs. If you said 1.498, I'm okay with that, but I bet you most of you probably said, hey, Mr. Duick, it rounds to 1.5 years. And again, 1 mark, half mark, half mark. Ooh, now they're asking me to find a speed. And now this one said give your answer as a percentage of the speed of light. So I'm going to write V equals question mark. I guess they told me time on board the spaceship, 8. Time back home, 100. So V is C times the square root of 1 minus, I think it's T0 over T all squared. It's going to be C times the square root of 1 minus 8 over 100. Here's what I know. In this fraction, the top has to be smaller than the bottom. That's how I know which one goes where. Because if the bottom was bigger than the top, you'd have 1 minus more than 1. You'd get a negative square root, and your calculator will give you an error. It's going to be the square root of 1 minus bracket 8 divided by 100, close bracket, squared, close off the square root bracket. And I get 0.996. You know, a good place to round off, maybe right by that 7, since there's a 9 there, and make that an 8. I get V equals 0.9968C, or 99.68% of C. If you said 97%, I'd be okay with that. If you rounded this to 100%, no, because we can't go the speed of light. We'll talk more about why that's the case today. Again, 1 mark, half mark for the numbers, and a half mark for the answer. Number 7 was in as a percentage of C. Number 8 wants the answer in meters per second. Hollis, how will I do that? Easy peasy. V equals question mark. They must have given me T0, 20. They must have given me T, 1,000 years. V is going to be C times the square root of 1 minus T0 over T all squared. Now I'll plug in the number for C, 3 times 10 to the 8th. It's going to end up being 3 times 10 to the 8th times the square root of 1 minus 20 over 1,000. Don't forget the squared. It's going to be 3 scientific notation 8 times square root button bracket 1 minus small bracket 20 divided by 1,000. Close off the small bracket, square the small bracket, close off the square root bracket. Did you get 3 nines, a 3 nines, and a 4? If you wrote that 2 out of 2, I'm going to round. I think the place I kind of have to round to is probably there, because if I round anywhere else, I'll be rounding it to 3 times 10 to the 8. I'll be saying you're going the speed of light. I have an issue with that. So it's going to be 2.9994. I'm going to write it in scientific notation. 2.9994 times 10 to the 8th meters per second. And again, I would give you 1 mark for the equation, half mark for the numbers, half mark for the answer. Can you give yourself a lovely score, please, out of, I think it's out of 18.